Alright, so we are looking at a few examples from our workbook. We kind of did that task already, so we're just taking that and going with this same thing and taking a look into some examples, some problems from the workbook. So make sure you have your workbook out and you're taking a look at them. So we use this to kind of talk about a lot of those shape and spread, talking about the modes here. So you should have this paper. You can use it and turn it in after if you need, whether it's skewed. We had a good example of skewed symmetric when it looks like that. Skewed to the right when the data is all on the left. Skewed to the left when the data is all on the right. Okay. Normal distribution is looking like this. It's when it's symmetric. Outliers, any, like if we had a number clear out here, an outlier. Variability, how spread out the data is. Okay, or not spread out it is. And remember, we also have, talking about our measures of center, that we mainly use the mean and the median to talk about those. Okay? So, let's take a look at these examples. Alright, so, example 1. 2 hockey teams recorded the number of goals scored each game in the following tables. Use the tables to compare the number of goals scored per game for the two teams using both measures of center and spread. Okay? So, we've got our data here for each one. So, why don't we, let's start out and make a dot plot for this one. Okay? So, let's have purple be the Ice Kings, and we'll go yellow for the Gliders. So 0 to 6 on both of these. Oops. I don't know why I went 0, 2. Okay. So we've got 1, 2, 3. 1, 2. 1, 2, 3. 1, 2, 3 threes. Then 1, 4. And 2 sixes. Okay. For the Ice Kings, 1, 2, 3. 1, 2. 1, 2, 3, 4, 5, 6. No 4s, 2 5s, and 1 6. And there weren't any 3s, were there, for the Ice Kings? Okay. So, we'd also want to find the mean and the median for each one. Okay. So, for the Ice Kings, we add up all their scores, and we divide it by 14. When we added it up, we got 30. Divide that by 14, and we end up with about 2.14. Okay. Then, when we go with the median, alright, we got 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, so it's definitely going to be 2, isn't it, for the median. Okay, we do the median for the Gliders. 1, 2, 3, 1, 2, 3, 3, 3. So again, same median of 2. Let's add up the mean. So I take all those and I add them up. And we get 33. Divide that by 14. we get about 2.36 when we round. Okay, so if we're comparing their centers, okay, according to the median, we've got 2 on both of them, don't we? Same median. For the mean, slightly lower for the Ice Kings. Okay. Now, if we look at this one's definitely unimodal, right? This one is multimodal because it's got 3 of them. The shapes are definitely, this one's pretty uniform. This one's a little more symmetric, but not by much. Okay, not by much, and they both are spread out from 0 to 6. Though I would say, since seems like the majority are down here, so maybe a lower variability for the Ice Kings than for the gliders. Okay, and that's kind of just take a look at those different aspects of it when we're doing it, and that's really all we needed to do right there. Okay, all right, let's take a look at example 2. So turn over to this one. So each girl in Mr. Sanson's class and Mrs. Quay's class measured her own height. The heights were plotted on the data dot plots below. Use the dot plots to compare the heights of the girls in the 2 classes. Okay, so again, we can find the mean and the median, being that we have the numbers, right, for each one. But we can do that after, because if we look, just looking at it, I can see that it looks like in Mr. Sanson's, it's almost more skewed to the left, isn't it? The majority of your data is up here. And it goes from clear down here to up here, where the majority of it, I guess the majority of it's right around here. They're about the same variability, right? So the different heights in the classes are different at about the same amount. Okay, but we can definitely see that Mr. Sanson was skewed more to the left. Mrs. Quay's is more skewed to the right, isn't it? So the majority of them are a lot lower in Quay's class than in Sanson's. Okay, so that's some differences in where the majority of the data is. They're both unimodal. Okay, but kind of uniform as well. Not a whole lot of differences in there. Okay, so let's now see the center. Let's see kind of how that different skewing affects our centers. Okay, so if we do median, that one's the easy one, right? We can cross them off. And we end up with 67 being the median of Mr. Sanson's, Mrs. Quay's. We end up with 65. Okay. Now let's see how the means measure up. So I'm going to take each of those and add them up and see what we get there. Okay. So Mr. Sanson's, I get a total of 1,662. Okay, we divide that by 25 students, and we get 66.48 for the mean. Now let's do it for Mrs. Quay's class. And we get a total of 1620, which we also divide by 25, giving us 64.8. So again, definitely we have a shorter class in Mrs. Quay's, because the center is median and then mean, whereas mean and median here. Okay, not by much, just a couple of I'm assuming inches. So there we go, kind of some comparisons there. All right, let's take a look at example 3. Now we've got box plots. Sam wants to buy a lottery ticket. There are 2 different tickets that he can buy, and each cost $10. He found a website with information about how much money others have won with their lottery tickets. The information is presented in 2 box plots as shown. Use the 2 box plots to compare the amounts others have won with ticket 1 and with ticket 2. Okay. Alright, so this is the money, I'm assuming. Okay, ticket 1 and ticket 2. So we know that this is our median here and our median here. Okay. So for ticket 2, the median was $5. Can't really find the mean off that, so we'll just use the medians. Whereas ticket 1 had a median of, I'm assuming that'd be $7.50. Assuming that it's right in between. So, ticket 1 definitely has a higher median score. So what does that mean? Okay. Well, remember, when we're talking about a box plot, we go from lowest to first quartile. That's a quarter of the data. Another quarter of the data. Another quarter. Another quarter. So actually, the longer the space, the higher the variability in them. Okay. And not necessarily more amounts, but actually basically less amounts, okay? So now the fact that we have the first and third quartiles, okay, they're quite a bit different, okay? So this one would actually have a much higher variability, okay, than ticket 1 would. Ticket 1 would have a lower variability in the majority of the times people have scored. Okay, ticket 1 also has a higher number than ticket 2. Okay, so the medians definitely one's higher, one's lower. Lower variability, which means you have more people, more data, centered around this is box accounts for half the data, and the interquartile range would be from 12.5 to 5 would be 7.5, as opposed to going from 2.5 to 17.5, a variability of 15. Exactly, right? So almost double, or exactly double, the interquartile range, which means this higher variability is much more spread out. Okay? Much more spread out. So you have people all over the place here, whereas it's more concentrated on ticket 1. So depending on what you would want, kind of determines, do you want to take a bigger risk, because there's a lot more variability here, or do you want to be pretty sure you're hitting within this range? The fact that it costs $10, right? $10 would put us right here, okay, and right here. So that's like, if you think about it from the median, this is half of our data, right? Half the people scored within this zone, and a quarter of the people scored within this zone, and then even half of a quarter scored within that. Whereas slightly more, a quarter scored this really high, and up here. I'd almost say ticket 2 might get you more chance at getting a higher than $10, because if you're losing less than 10, you're probably not too happy with that, are you? Okay? Alright, so there's a few examples. Now turn the pages till you get to this practice 4.1.2, comparing data sets. Okay, and we're looking at the B part, not the A part. Okay, so we're going to kind of do these together, and then you guys will be able to work on some on your own. Okay. Alright, so let's take a look at this. and give you a second longer to flip to the right page. So it says determine which measures of center to use to compare the data. So in other words, do you want to use the mean or the median? Okay. Think about which one you'd want to do. Then find them both, because part 2 is finding. Now, I don't care about the mean absolute deviation, so instead find the interquartile range. And then I want you to kind of compare them a little bit using either the mean or median, whichever one you chose, and the interquartile range to talk about them. Okay? I want to give you guys a few minutes to try this one on your own. But I want you to, I want you to try to determine which mean or median you would use. And then also get the interquartile range, and then describe any similarities and differences between the data sets. You're more than welcome to put these in the calculator and graph them out together. And I don't think I've shown you guys how to do that exactly yet when you have 2 sets of data, so we can do that when we get back as well. Okay? Alright, so pause it right now. Alright, so let's take a look. And honestly, before I do the mean or median, I would probably find them both. Now remember, the mean we can write with that X and a little bar over it. So I'm going to put it for each side, and I'm going to actually find both. And we'll just have the M for the median. So for class 4, we get a mean of 9.4. I believe I had a total of 141, which we divided by 15. Okay. So now let's do the mean of the class 2. And we get a total of 130, which divide that by 15 gives us 8.6 repeated. Now, to find the median, let's start with the lowest. These are 2 science classes. Oh, how old they were when I rode on the plane. I was wondering what they were comparing. So lowest to a highest, highest to another lowest. Trying to save time by not writing these in order. 13 and 3, then 12 and another 13 and 4, then 12 and 6, then the next 7 and 11, 9 and 11, so a median of 10. Okay, so we can see there's a bit of a difference in which one you would use. Okay, so class 1, high of 15, low of 2, low of 3, high of 15. Next one down is 12. Next one up is 8. Then 8 and 11. Then 11 and 9. 10 and 9. 10 and 9. We end up with 9. So in class 1, they're about the same. And I wonder if because you have a bunch lower, that I would almost say I probably would have went with the mean in this case, comparing those. Okay. All right. Now interquartile range. Maybe I should have written these in order, huh? Because to find the interquartile range, that could have been a lot easier having them written in order. So on class 2, we knew that our median was 10. Okay, so then for our first quartile, we get 4. For our third quartile, we get 13. So then interquartile range is 13 minus 4, or 9. Okay. Then we do it for our class 1. Okay, for class 1, we knew that we had a median of 9. Though I don't remember which 9 it was. I want to say it was that 9. So let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, it was that 9. There's our median. So 1, 2, 3, 1, 2, 3. We have a first quartile of 8, 1, 2, 3, 1, 2, 3. Third quartile of 11. 11 minus 8 would only give us 3. So definitely class 2 has a higher variability, okay, which we see in the higher difference in our median and our mean, whereas this interquartile range of 3 means it's not quite as spread out. So if we compare them, class 1 has a higher mean but a lower median than class 2. Also, its spread has a lower variability, whereas class 2 has a higher variability, much more spread out. But they both have pretty similar median and pretty close on the mean. So, yeah, there we go on those first 4. Okay, now we've got 5, 6, 7, and 8. So you're going to determine the minimum, maximum first, third quartile, median, create a box plot, compare the center and spread of the data from each day, and then answer. Chloe has the option of working on either Tuesday or Wednesday. Which day should she work? So you're going to come up with a problem here. So probably another 5 to 10 minutes for Chloe, who works at a clothing store, and she's recording how much she earns on her commission. Okay, so compare these two. You can use the calculator if you want or not, but pause it right now and take about 10 minutes. So I've already put them in order to make it a little easier. So the minimum, yellow will be in Tuesday. So the minimum would be 5, maximum 2140. Okay, now the median. So we'd go 1, 2, 3, 1, 2, 3, 1, 2. So it's between 1440 and 1560. So I go 1440 plus 1560. I've got a calculator, which is 30 divided by 2, be 15. So median right there of 15. So then first quartile, cancel those two out, and we get 1240. And then third quartile, cancel those two out, and it'd be 1710. Okay, then for Tuesday in our box plot here, I've got it down right here, minimum of 5, maximum of 1710, or no, maximum of 2140, so like right about here, median of 15, third quartile of 1710, so almost halfway, and then 1240, so almost halfway, would look something like that. Okay, then we do Wednesday. Okay, up here at the top, so it's got a minimum of 560, maximum of 3370. Oops, maximum 3370. Don't know where I am putting it in the wrong place. Okay, then 1, 2, 3, 2, 3, here. So then it's between 2290 and 2410. So I go 2290 plus 2410. It's 47. Divide that by 2. We get 2350 for our median. 2350. Okay. Then first quartile, we get 860. And third quartile, we get 2990. Then we graph this one. So this is Wednesday, right? Yeah. So low of 560, high of 3370. Okay, a median of 2350. 29 for third quartile, and then for first quartile, clear down to 8. Okay. So, compare the center. Well, Wednesday's median is much higher than Tuesday's median, right? And that means the middle of our data, right? So, half of our data is here, and the other half here, compared to half your data here and the other half here. So Wednesday has a much higher spread, much higher variability, okay? And, yeah, a low is about the same, definitely higher on Wednesday to the high, and so much closer together, lower variability for Tuesday, higher variability for Wednesday, okay? If we look at it, it's like half right here. It takes up that whole graph, basically, okay? So this one's probably a little bit more uniform than this one, but they're definitely spread out a lot. So it says, next week, Chloe has the option of working on either Tuesday or Wednesday. Which day should she work? So looking at this and thinking about that half my data is right here, that means half my commissions are going to be above probably $20 or so. Okay, whereas nothing really, no sales on Tuesday get up to that price. For me, I would definitely work on Wednesday, based off the fact that half my money or half my sales are going to be in those higher money options than the lower. For same amount of work down here, I'm earning a lot less than I possibly could up here. Now, will I get pretty spread out here on the bottom? Yeah, but I've got a lot more chance of at least half my sales being in that higher dollar, which I think is what you guys would want. All right, so there we go. Okay, really quickly, schools in Florida and South Carolina were surveyed about the current price of a school lunch. The responses to the surveys are in the following dot plots. Use the dot plots to complete problems 9 and 10. So looking at this, South Carolina, which appears to have the higher mean cost for school lunch. Okay, well, being that, kind of looking at our mean, it's going to be probably around here. For Florida, going to be a little bit more, probably right here. So I would say that Florida has the higher mean, based on a lot of the data is just right there. And so that's going to kind of keep it in that zone, whereas there's a lot more spread down here that kind of offsets those big ones, and it's going to be lower for South Carolina. Which state appears to have the higher variation in school lunch cost? Well, we go from 1 clear up to 3, and a lot more options here. So I'm going to say South Carolina probably has that higher variation there. Okay, so I know we just kind of looked at that one pretty quick, but we were running out of time here. So if you can, I want you guys to work on this at home and try to do the 8 part. There's 10 questions here. So the A, starting here, questions number 1 through 10. Try to get those done so that we can talk about them next time in class as well. Okay? Other than that, there we go, guys. Let's call that good.